In this video, we're going to do another example of a type 1 improper integral, where one of our bounds is infinite. And in this case, this is part 3 of the definition, where both ends of our bounds are infinite. So we're looking at the graph of 1 over 1 plus x squared, which is shaped like this. And of course, I have the area written on here. The area is pi. This is going to be a finite or converging improper integral. So part 3, we're going to have to separate this into two integrals so that it looks like part 1 and part 2. So the way I'm going to do this is I'm going to say, well, this is the integral from negative infinity to 0 of dx over 1 plus x squared plus the integral from 0 to positive infinity of dx over 1 plus x squared. So in the blue one on the left, that first bound on our limits of integration should be my a value. So in this case, this is going to be the limit as a goes to negative infinity. And on my second integral, the upper bound on my limit of integration, which would be b, is going to be positive infinity. So I'm going to set this up. I have the limit as a approaches negative infinity of the integral from a to 0 of dx over 1 plus x squared plus the limit as my b value approaches positive infinity from 0 to b of dx over 1 plus x squared. Now, in order for me to evaluate each of these integrals, I would be looking at a table integral. This is actually the integral of tangent inverse, where that a value is 1. So that's number 17 in your table of integrals. And this is equal then to the limit as a approaches negative infinity of tangent inverse of x from 0 to a. And the integral is going to be the same for this second. It's just the bounds are different. So the limit from b to positive infinity, and again, we're going to get tangent inverse of x evaluated from 0 to b. So now I'm going to plug in my zeros and my a's and b's. I have the limit as a goes to negative infinity. I'll plug in 0 for x and then a. I have tangent inverse of 0 minus tangent inverse of a plus the limit as b approaches positive infinity, tangent inverse of b minus tangent inverse of 0. Tangent inverse of 0, both of those values are going to go to 0. So I'm dealing with the limit as a approaches negative infinity of negative tangent inverse of a plus the limit as b approaches positive infinity of tangent inverse of b. At this point, we're going to evaluate our limits, and we want to think about what the graph of tangent inverse looks like. So just a refresher, y equals tangent inverse of x. That graph looks roughly like this, with a horizontal asymptote up here at positive pi over 2 and a horizontal asymptote at negative pi over 2. Remember, when we were dealing with inverse trig functions, we restrict the range to make sure that that inverse expression is indeed a function. So if I were to plug in negative infinity to tangent inverse, I would see that my output value is negative pi over 2. And if I were to plug in positive infinity, my output would be positive pi over 2. So I have negative tangent inverse of negative infinity plus tangent inverse of positive infinity. And through more precise mathematics, we can show that that limit is negative and positive pi over 2. But for the sake of time, we said that is negative pi over 2 plus this one is positive pi over 2. These two negatives cancel. It's positive, and pi over 2 plus pi over 2 is just going to give us 2 pi over 2 or pi. So the value of the improper integral, the area under the curve from negative infinity to positive infinity for this function, 1 over 1 plus x squared, converges to the value of pi.